Welcome back. In today's video lecture, we will discuss about how to compute electrostatic fields due to single point charge and also multiple point charges. In the last video lecture, we have gone through the Coulomb's law and determining the force between different charges which are located in space. But in this video lecture, we will see the derivations. The expression, we will derive an expression for computing the electrostatic fields due to a charge at a particular point. And next we will move on to determining the electrostatic field for different charge distributions. So before I start with the deriving the expression for electrostatic field intensity, let's have a quick look about electric field intensity, which we have discussed in the last lectures. Electric field intensity is normally defined as the force per unit charge. In the last video lectures, we have seen that if there are two charges, then automatically there will be a force between these two charges. Let us suppose this is the force which is exerted by Q1 on Q2. Right. Now, this is the force which is exerted by Q1 on Q2. Now, let us suppose if I bring Q2 to here. This is called as an electric field. Electric field due to 1 at the point P, where Q2 was located. So, electric field is defined as the force per charge. If I consider it as 1, so force per unit charge. So, electric field is the force per unit charge on a test charge at a particular point. And it is a vector quantity. Normally, let us suppose if we consider a point Q plus charge, the electric field will be directed away from the charge. If it is a negative charge, then automatically it will be directed towards the charge. And electric field is normally represented by the letter E, since it is a vector quantity. In most of my contents of the course, I will represent it as capital E, which is bold. I will use a bold letter of E, or I will be using E bar, which indicates that it is a vector. And the units of this are newtons per coulomb, or you can employ volts per meter. These are the SI units. And as already I mentioned, electric field intensity due to a positive charge is always directed away from the charge, and intensity due to a negative charge is always directed towards a charge. Having said this, as we have seen in the last slide itself, due to a point charge Q, let us suppose if a point charge is at Q and there is a distance P, let us suppose this is O, where Q is placed, and this is a point P which is at a distance of R. R is a distance. Now, the electric fields at this particular point P is given by Q by 4 pi R square. Sorry, epsilon will be there. And since it is a vector, as we have already seen, it is a unit vector which is directed along this distance. And the units are Newton per coulomb, or you can use volt per meter. So this is the expression. E is equal to Q by 4 pi epsilon naught R square UR, where UR, as already I said, it is the unit vector from the location of Q to the point P. This is the unit vector. Now, if there are multiple charges, let us suppose there is a Q1 here, there is Q2 here, and there is somewhere Q3 here, and there is somewhere Q4 here. All these charges, and I am considering a point P here. So, all these charges, they will exert an electric field on this one. Assuming that all are positive charges, I am considering them as the fields away from those charges. So let us suppose the field exerted by this is E1, this is E2, this is E3, this is E4. Now the net field at this point P is equal to vector sum of these charges. See, if we have array of charges which are at distances R1, R2 and R3 from the point P, then the effective field is given by this is the equation. You know the E1, E2 and E3, all these are basically vectors. So E1, E2, E3 up to E. Right. So now so far we have gone through only point charges. Now let us suppose if there is a surface charge in the sense that which is spread over a particular surface. So if it is spread over a particular surface, then automatically we may not be able to compute the entire charge, and most of the times your questions will not be having any entire charge given on that surface. So what they will mention a surface charge density. So I'll take a right, this is just like a cuboid which is having six faces. See, this is one face, and this is bottom face, and you can see 1, 2, and backward is 3, and this is 4. So it has 6 faces. Now it is a 3-dimensional object, and if you take any face, each face is basically 2-dimensional. So if a charge is spread over this particular face, then it is called as a surface charge. Now it is a surface charge. This is occupying 2 spaces. Which is a 2-dimensional thing. So we have seen this 2-dimensional and 3-dimensional elements in the previous lectures. Now if a surface charge is being given for you, so instead of mentioning the entire charge which is there on the surface, what they will do is nothing but they will mention only charge density. They will mention only charge density. They will state that the surface is having charge density of sigma coulombs per meter square, and area you are supposed to compute. If it is a cuboid, you know the area of a face area. This will give you your charge. But all the times we may not be getting a surface where we can easily compute the surface area. See, for a cuboid we can compute the surface area. It may be some length into breadth or length into height. If it is a cube, then automatically it will be S into. So in that case you may not be able to solve the equation for this charge. So if the surface area is unknown, there is no clear expression for determining the surface area. What we will do, we will just write it as ds and we will integrate over this entire surface area. Otherwise, if you know the surface area very clearly, then directly you can employ into that area. If you do have a very firm area where you know the surface area, equation for surface area, you can directly employ this equation. But if you don't know, if you don't have a clear shape of your surface, then it's better if you go with surface integral of that surface area. Okay, so this is the expression. This can be written like this over the closed surface. Okay, now what is the expression now? So since Q is represented like this, you know that E is already equal to 1 by 4 pi epsilon naught Q by R square into UR and by Coulomb. So instead of Q, you will be placing this entire thing. So now what it will become? Instead of Q, what I have done? I have placed it this way. This is the expression for electric field due to a surface charge. Now let us suppose if there is a volume charge. You know that for a volume charge, basically, what you will be having? You will be having a volume charge density. And how you will determine the volume? Volume is equal to integral of V over the entire volume, rho V into dV, right? If it is a function of R, then you will write it like this. If it is not a function of R, then automatically what you will do? Okay, so this is Q. Now you know the electric field equation. You will substitute the value of Q here. This is your expression. This is the electric field due to a volume charge. So based upon the charges which you have, if you do have point charge, you can directly employ the basic equation. But if you do have charge distributions, you are supposed to employ these equations. So based upon the charges which are available for you, you need to choose proper expressions for determining the electrostatic field. I hope now you are able to choose proper equations for determining the electrostatic fields. And I hope that you are able to develop an expression for determining the electrostatic field for different charge distributions. Thank you. And this is a question. How will you determine the electric field intensity at a point due to a surface charge and volume charge acting simultaneously? So if this is the case, you know that you might be experiencing two different types of things. So which means that you do have a surface charge and also a volume charge acting simultaneously. You know that we have already discussed that one. E is equal to, you will get E1 bar plus E2 bar. For E1 bar, since it is due to surface charge, what I will be getting 1 by 4 pi epsilon naught integral of over the surface. What I will be getting? Charge density, right? If it is a surface charge, I will be getting a surface charge density. So rho s into ds by r square, right? Into ui plus, let us suppose this is R1 because of the first thing. I'll write it as UR1. For the second one, it will be over the entire volume. You are supposed to integrate it. Assuming that these are functions of R. UR. Like this. This is the simultaneous application of two charges. One is a surface charge, the other one is a volume charge. Okay. Thank you. In the next video lecture, we will see simple problems on how to determine the electrostatic field. Thank you.